quest on Friday. I'm going to call it a quest. Sounds nice. So we'll review tomorrow for that. And then we're also going to review completing the square tomorrow. Because we're going to use completing the square to help us with conics. Conics, like completing the square process is a key component of conics. So there's no like quadratic formula, but we need to use completing the square to get it in a certain form. And that's what completing the square helps you solve, but it also helps take an equation from one form and place it into another form. So we're going to review that a little bit, hopefully refresh, remind you. Chelsea remembers, she's good.
Oh, completing a square. I honestly couldn't tell you how to do that. Actually, maybe.
I could.
Oh, Kate said me. I definitely remember. I'm
Divided
going to
by
teach tomorrow.
two. Isn't that a
No,
thing?
it's a 2 and a half.
Oh, you're in line.
Divided by 2.
Unless Brandon lets you go first.
Yes?
Brandon might.
Maybe. I don't know.
Miss Kate, is it b divided by 2?
It is squared.
What is b over a
Right.
then? What a thing.
Well, negative b over 2a is the axis of symmetry.
That's it.
Can you make it?
I'll tell you about that.
Well, she has the pass right now.
Oh, I didn't. Okay, that's where I'm confused. I'm good.
Yeah. Sorry. All right, so I'd like to go over a couple of these. I wanted to start with number 4. So number 4 at the bottom of the page was talking about baking bread. And Tony with an I bakes 2 different types of wheat bread, which if I make bread, I'm not making wheat bread. But that's her prerogative, I suppose. Recipe A calls for 3 cups of wheat, 2 cups of white flour. Recipe B calls for 2 cups of wheat and 4 cups of white flour. She has 12 cups of flour and 16 cups of white flour. So clearly she already has everything measured and she knows how much she's got to work with. If she has enough of all the other ingredients, how many loaves of each type can be baked? So how many loaves of each type? When you look, if you're not sure like how to define your variables, if you look at the last part, that usually kind of explains what you're trying to solve for. So we're trying to figure out how many loaves of recipe A, how many loaves of recipe B we're supposed to be able to bake. So I used A and B just because A and B were in the equation or in the information. You don't have to use A and B, but sometimes I like using the letters that are in the problem when I define my variables. So A is the number of loaves for recipe A. B would be the number of loaves that we can bake with recipe B. So can I make 3 with A and 4 with B? Something similar to that. So if you come up then looking back in the problem and trying to create an inequality. Yeah, inequality. Okay.
I did like,
Yeah.
what I had was 3W plus 2W is less than equal to 12.
Okay, so instead of saying W, I'm going to say, you said 3W.
Yeah, because I just use like for the wheat flour.
Alright, so instead of using wheat flour, we have 3 cups of wheat for recipe A, and then 2 cups of wheat for recipe B. And then you said less than or equal to 12. So even though you're not using like a W for a wheat or like a W variable, this whole inequality still represents wheat because all of the values are correlating with the wheat information. But the A variable says I need 3 cups of wheat for A. The 2 means I have 2 cups of wheat for B. The 12 is the restriction on the number of wheat cups of wheat. So Michael, if you kind of use that same information and come up with an inequality then for the white flour.
And then I would have to be 2A plus 4B is less than or equal to 16.
So then that would describe the constraints or restrictions that you have on the white flour. The other 2 are just going to be the A and B greater than or equal to 0. You do need to have both of them. Questions on that? So if you're not sure what your variable should represent, go to the last sentence. Usually that last sentence describes what you're trying to solve for. So we're not trying to solve for like the number of cups I'm supposed to use. We know that information. We're trying to solve for how many loaves of each type we get. Questions? So then if you flip and look at the corn and plant beans. Got a farmer, she's planting corn and beans, and she has 10 days to plant them. So I'm sure there is probably a specific time that you can plant those veggies to get them in so that they grow in the proper amount of time so they're ready in the correct time frame. She has corn that she can plant at a rate of 12 acres a day, beans at a rate of 9 acres a day. She has 100 acres available for planting. How many days should we spend planting corn or planting each crop? So if you want to use a C and a B, an X and a Y, it doesn't really matter. Brandon, how'd you set up yours?
I had x plus y is less than or equal to 10.
Okay, so X represented,
Corn, number of days for beans.
Yep.
And y represented the number of days for beans.
I flipped my R and C. And it is the number of days with each one of those. Okay, so you said the first one was,
X plus y is less than or equal to 10.
so X plus Y equal to 10. So number of acres that I plant for one variable and the number of acres that I plant for another each day, I have 10 days to plant them. And then the other one, Brandon, you said,
12x plus 9y is less than or equal to 100.
and that's because I have 12 acres every day for corn, 9 acres every day that I can plant for beans. Okay, and again, we have at least a total of 100 acres available for those two crops. And then finally, greater than or equal to 0. Any questions on that? So number 6 is Amy and Bill. They're making some kind of toy. And when I read this question, it reminds me of Rudolph, the movie like that. I don't know, I guess it's considered a movie. Like that old school Rudolph with, what's the little elf's name?
Are you talking about the cartoon?
Yeah, the cartoon. What's the little elf?
Randy.
Or, I don't know, but they're in that, like, they're in Santa's workshop and they're making those, like, little old school wooden toys. You guys know what the show I'm talking about?
Yeah.
Cartoon.
I just don't know.
So this type of toy, like, reminds me of what they were making, because I think that show was made in, I don't know, like 50s, 60s, it's really old. We have the classic series collection of Rudolph and Frosty and Frosty Returns and something else. The girls don't watch it anymore though, because we're too big for that. So Amy and Bill making 2 types of toys, Santa's Workshop toys. Toy A has a spool, a wheel, and an eyelet, 9 eyelets. Toy B has 4 spools, 2 wheels, 5 eyelets. Libby, what do you have here?
It's Hermie.
Hermie.
Yeah.
Hermie. And he wants to be a dentist, right?
Yeah.
Yeah.
Did you Google it? Yeah, I did. I can still.
Thanks,
understand
Libby.
it.
I appreciate it. So how many toys of each type can they make? So again, I use A and B, but you don't have to use A and B. So number of toy A, number of toy B. Libby, how did you create your inequalities?
So I did it by each thing,
Yeah,
the
whatever
schools.
they are, yeah.
I did x plus. Well, I used x and y.
No,
so
that's okay.
I'll do a plus 4b is less than or equal to 16.
So that's the number of spools. So each type of object that you need to use to make this toy. The second object would be the wheels.
And then I did a plus 2b is less than or equal to 12.
And then we have these eyelets.
And then I have 9a plus 5b is less than or equal to 90. And then I have a is greater than or equal to 0, and b is greater than or equal to 0.
That one was similar to maybe the one we looked at in class. Any questions with that one? Yeah, pretty sure like similar to the calories and vitamin problem, just the inequalities are flipped because the one we did yesterday said at least, where this one is saying that's the most they have. We'll have to look up what a spool, a wheel, and an eyelet make, and toy those make. So the last one was a dog problem. And this kennel, which apparently a couple of people throughout the day thought that this was one dog eating 50 pounds of food. I think the dog would be dead. That's a lot of food. Like an elephant might eat 50 pounds of food, but a dog? It's pluralized, dogs in a kennel.
And then it said the dog.
Yes, apparently that S got dropped. I don't know, and there was more than one person who said that. Two different types of dog food. So we have each pound of brand X has 1 unit of protein, 0.25 units of carbs. Each pound of brand Y has 0.25 units of protein, 1 unit of carb. The dogs consume at least 50 pounds of food each day. Again, not one, or less. Who knows how many? Their daily diet should have 30 units protein, 20 units of carbs. So X, I said, were the pounds of dog food X, Y, pounds, dog food Y. Kate, do you want to take a shot at it?
So I had X plus Y is less than or equal to 50.
And that would be because,
That's the units of weight. Why would I do that?
you're right.
I don't know why. I did
Actually,
that.
you're really close. So it says at least 50 pounds of food each day.
Oh, is it pounds?
You're right. It's just this little symbol here. If it's at least.
Oh, it's food.
Created and equal to. Yeah, between the two types of dog food, the dogs are going to eat at least 50 pounds. So X plus Y greater than or equal to 50. Kate, how about the next one?
I had X plus 0.25Y is greater than or equal to 30. So that's the protein.
Yep.
And then I
And
had
then the carbs.
0.25X plus Y is greater than or equal to 20. Or plus 2, yes,
And that was the
carbs.
carbs. Yeah. And then again, X and Y greater than or equal to 0. Any questions on trying to rank those ordered pairs? Not ordered pairs, inequalities. Any others that I didn't go over? But the last 4 were a little more interesting. And the wording there. So we're going to go through one big problem today, and it's on the last page of your packet. There are 3 parts to the problem. You'll have 2 that are like this tonight, and it's 39 and 40, and those are the 2 that will start in class. You should have picked up like the big sheeted graph paper where it's just like a grid on both sides, and that would be the graph paper that you would want to use to graph the 2 problems. So we'll work through the steps, the 3 steps that are involved to kind of solve through a big word problem. It's called linear programming, but essentially we're going to create the inequalities, graph the inequalities, and then see if we can kind of analyze that information to try and find an objective quantity. What's the goal of the question that they're asking? So see if you can read through. This one says finding maximum profit. So that's our goal. What's the max profit? How can we make the most amount of money? But read through the information. Try and write a system of inequalities for the information that's given. There's a lot to look at. Some of the information is extra that it's not going to be part of the inequalities. Bless you. Michael, do you have an inequality?
Yeah, I have, x plus y is less than or equal to 60,
And why did you write that?
because it says they can make a max of 60 printers a day, so, yes.
So there's 2 printers combined together, maximum 60 printers a day. And it did already define the information in the parentheses here, so we didn't need to worry about writing that extra stuff. Alright, so that would be one piece of information we can gather. Brandon, and another one.
X plus y is greater than or equal to 10.
You're so close.
Oh,
Trying to find that right here.
X is greater than or equal to 10 and y is greater than.
Yeah, so because it says each, so individually, each of them, we have to make 10 of each. So X, the inkjet, we have to at least make 10 of, and we have to at least make 10 of the laser printer. So individually, I have to make 10 of each of them. That's so that our people aren't slackers. They don't just go to work and stand around and talk. We gotta do something. Chelsea, one more inequality.
X plus 3y is less than or equal to 120.
And you got that because
Of labor hours.
yeah, the hours of labor. So the sentence where it talks about profit being $40 for an inkjet and $60 for a laser printer, if they don't give you a constraint or a restriction that goes along with that information, you can't write anything like for an inequality dealing with that. But I can't say like 40x plus 60y should be greater than or equal to an imaginary number because I don't know what that number is. So that actually is extra information that we'll use later on in the problem. So the 40 and the 60 are not part of your inequalities. That's just separate that we'll use to figure out profit, because that's what we're trying to find. So if you look at the second part then, so step 1, come up with your inequalities. Step 2 would be to graph them. So we'd have to get them in y equals form. It says that we're supposed to label our axes because this is an application problem. So the x in the problem was inkjet. The y is the laser printer. And then we'll also have to determine what to count by. After you see what your intercepts look like, your y-intercepts, you can kind of determine how you should count, how you should label your axes. So again, we have x greater than or equal to 10, y greater than or equal to 10. Chelsea, in y equals form, what would the other inequalities be?
Y is less than or equal to negative x plus 60. And then y is less than or equal to negative 1/3 x plus 4.
You said 40.
Yep.
So we have 60 and 40, and you could probably say, well, I could count by tens. But if you count by a lower number and it works, sometimes it makes the graph less squished, easier to look at to gather the data that you need. And I think counting by fives would work as well. So if you can count by fives, use the whole graph. So if we counted by tens, it would be a tiny little graph, which is okay. It still works. But counting by fives, I'm pretty sure you guys should be able to get to the top and still have a space left over. And you don't need to label all of them. Labeling every other one is okay as well. But whatever you count by on one axis, make sure you're counting the same way on the other axis. That keeps them equivalent when we're trying to graph with the slope. So that'll be like the bigger the number, kind of depending on how much space you have, you'll have to kind of see what you're going to count by. But whatever you decide to count by, you want to make sure your intercepts are divisible by that number. So don't use a random number of 8 if you can't divide them both by 8. And we have a vertical line for x is greater than or equal to 10, and a horizontal line, y is greater than or equal to 10. So this is not at 0, 0, because we have to at least make 10 of each. Our employees must do something when they go to work. Making sure you're at the y-axis when you go up to 60. And then with the slope, because you counted with the same increments for x and y, you're still going down 1 over 1. So down 1 over 1, yes, you're going down 5 and over 5, but that still is the same slope of negative 1. And then the final line we have at 40, and that one is down 1 over 3. Again, you're still equivalent, you're going down 1 over 3. We can do that because we counted by the same increments for x and y. Where do we shade?
The quadrilateral in the middle of the graph.
Yeah, so it is above the vertical line, to the right, above the horizontal line, to the right of the vertical line, but then it's below the two diagonal lines, because those two are less than. Yesterday, the one that we graphed was unbounded because it was above, everything was greater than or equal to, so it was above everything. And then the last piece of information that you'll want from this graph are the vertices, because where they intersect will help us determine the max profit, or if I wanted a minimum cost that it would take me to make them, we would find that a minimum cost. So we need those 4 vertices, those 4 intersection points, and that's called the corner point principle. So the corner points will give us a max or a min value. Anything in the middle would give me a number that would be in the middle of the data. So looking at our information, we have a point at 1010. There's a point at 5010. One here at 3030. And then the last one is at 10. And something in between. It doesn't meet in the direct corner of a box. How can I figure out what that is if it doesn't meet in the corner of a box? So we're looking at this point right here. It's in between 35 and 40. How can we figure out the exact value? Michael?
You still plug in 30.
Have to plug in? Yeah, 10. Because we know x is 10, I want to figure out what the y value is. So if you take this equation, well, my red line equation is negative 1/3 x plus 40. We do negative 1/3 times 10 plus 40. I know the x of that ordered pair is 10. I need to figure out the y of the ordered pair. And it's not meeting in the nice corner of a box, which is okay. If I didn't know what x was, I'd take the one line and set it equal to the other line and solve for x. So if they don't meet in the nice corner of a box, you just take one line, set it equal to the other. And Michael, that's what it's going to be.
What if you like 36.67 or something?
Yeah. So 36.67, 36 2/3, 36.6 repeating. Technically, you can't make 2/3 of an object, but I mean, they could maybe just not finish it and make it the next day. Their shift was over, so part of it got made, and they're going to finish it the next day. So the last part of the problem, 3 pieces here, says write an equation to represent the maximum profit. How many of each type of printer should be made so that we can make the maximum daily profit? So if you go back up and look at the word problem, Harris, is there anything that talks about profit in that word problem?
40x and 60y.
Yeah, 40x and 60y. So that's how I would get the max profit, by taking 40 times the number I make for x, 60 times the number I make for y. And then if you just take those ordered pairs, the one is probably pretty obvious that the 10-10 is not going to give us a max profit. I mean, those are the smallest pair of numbers. But then we had a 50-10, we had a 30-30, and the other one was a 10 and the 36 2/3. So you're going to plug them in, calculate what the max profit would be, and how many of each type of printer we should make. think the first one you probably could do mentally, Brandon, 40 times 10 and 60 times 10?
That would be 400 plus 600, which equals 1,000.
Yeah, so I think that one is doable without a calculator. That first one's 1,000. Libby, how much is the second one? 40 times 50, 60 times 10.
2,600.
Yeah, 2,600. So 4 times 5 is 20, add the extra 2 zeros. 6 times 60 times 10 is 600. How about 30, 30? Chelsea? 3,000 even. The last one having that decimal, I guess that might be a little rougher trying to do in your head. 40 times 10, 60 times 36 and 2/3. Brandon?
I got like 2,600.
So if you wanted to make the most profit, $3,000 a day would mean that we would make 30 of each printer. Since that ordered pair was 30/30, for a profit of $3,000. Which probably isn't too bad for a small company, $3,000 at the end of the day. $15,000 at the end of the week.
Can you look at mine? 'Cause my points don't have to do this.
Yeah. Somebody else needed. So I have like a little sheet that I wanted to type up. So 39 and 40 I have on this little sheet. And I typed it up because I kind of wanted to like clarify it compared to what the book had. So I feel that this is a little clearer to understand. I'm going to go through the first one so that we can create those inequalities together. And then you'll have time to graph them. So this is number 39 and 40 from the homework. These are the two big problems. The other ones you have to graph, not all of them. But some of them you'll have to graph, but you don't have to go through like the whole application process of creating your own equations. So an accounting firm has 800 hours of staff time, 96 hours of reviewing time available each week. And then it talks about how much they charge. And then it says an audit has 100 hours of staff time, 8 hours of review time. A tax return has 12 and a half hours of staff time, 2 hours of review time. So when you look at part A, what number of audits and tax returns will yield the maximum revenue? That sentence there tells us what our variables are going to represent. So audits can be X. The Y can be the tax returns. So you don't really know what X and Y are until you get to that point. So then if you go back through and pull that same piece of information together so that you're looking at all of the same pieces of information. So it's the first sentence goes back and it says you have 80 or 800 hours of staff time. So that's the max amount of staff time that we have. So that has to be involved in one of the inequalities because we have 800 hours. What would go with that 800 hours? Chelsea?
100x and then 12.5y.
And those two numbers also deal with the staff time. So the hours that the staff will be putting in to each of those two pieces, an audit and a tax return. The second part of that first sentence says we have 96 hours of review time. So after you do the audit or the tax return, somebody's going to look over it to make sure it's okay. It was done correctly. And that would be, looks like 8x and 2y. So 8 hours for the audit, 2 hours for the tax return. And then, of course, we have our x and y being greater than or equal to 0. So you're going to want to take these two inequalities, get y by itself. It does work out nicely. And then once you look at your y-intercepts, decide what to count by. So use the y-intercepts when you're deciding to count. Counting by 5s doesn't work for this problem. It won't work out nicely. Your point will be in the middle of 2 boxes. So you don't want to count by 5s. Questions on that, creating those inequalities? So the second question then is similar. There's a little chart. So the data I organized in a chart for you to kind of look at and read. And then the other problems are not word problems. They're just kind of going through and regraphing, reviewing the graphing. You have a little bit of time that you might be able to graph, or at least label your axes.